Okay, with respect to factoring quadratics, there are two special cases that are super helpful to be able to factor super fast. So, first one is called the difference of squares, x squared minus 16. And the pattern you're going to see is this. We have x minus 4, x plus 4. Now, why does this work? Well, hopefully you can see x times x gives you the x squared. Hopefully you can also see that a negative 4 and a positive 4 gives you the negative 16. But why are there no terms in the middle? So the reason why is, let's look at inner loopy. Inner loopy is negative 4x. Outer loopy is positive 4x. Positive 4x minus 4x, they cancel each other out. That's why there's no x's in the middle. Let's try this one. X squared minus 9. Give it a try. So hopefully you see the pattern. The square root of 9 is 3. So we got some pluses and minuses. And when we multiply this out, you have a negative 3x. You have a positive 3x. And the inner loopy and the outer loopy cancel each other out. And of course, you have x times x gives you the x squared. Negative 3 times positive 3 gives you the negative 9. Okay, let's kick this up a notch. Let's say you had something kind of horrendous like this. 25x squared minus 36y squared. Well, let's try factoring this. We have something here and something here that have to multiply to be 25. So if we put a 5 and a 5, 5 and a 5 make it 25. We also need an x squared, so let's give both of these guys x's. Now, we also need to get a negative 36, so we're going to do minus 6 minus 6. We also need a y squared, so we're going to do a y. Actually, sorry, I made that guy a plus. Okay, so if we multiply this out now, we've got 5x and 5x gives you 25x squared. We have negative 6y and positive 6y. Negative times a positive gives you negative 36y squared. And the inner loopy is going to be negative 30xy. The outer loopy is going to be positive 30xy, but the inner loopy and outer loopy cancel out. And so your answer is just this. 5x minus 6y in one set, 5x plus 6y in another set. And you can do the same kind of logic with something like this. X to the fourth minus 100. Well, that's going to be x squared minus 10, x squared plus 10. Check this out. We've got x squared and x squared. X squared times x squared is going to give us x to the fourth. Inner loopy, negative 10x squared. Outer loopy, positive 10x squared. Cancel each other out. Negative 10 times positive 10, negative 100. Now, one word of caution, it would seem very tempting for something like this, x squared plus 16 to be factorable. That is not factorable, at least until you understand imaginary numbers a bit better, so this can't be factored. And why, you say? You say, shouldn't it just be x plus 4, x plus 4? And that would appear to work, but the problem is x and x give you x squared. Okay. 4 and 4 give you 16, so you're like, wait, this is working, but inner loopy 4x, outer loopy 4x, so this doesn't work. This would be equal to x squared plus 8x plus 16. So this is not factorable, at least without some imaginary numbers. Okay, last special case is something called perfect squares. Speaking of perfect squares, we just had x squared plus 8x plus 16. We can write this as x plus 4x plus 4. Basically, you can think of this as taking the square root of 16 and going right there. Or you could also think of this as taking half of 8. So let's see if we can see a pattern. Let's say we have x squared plus 6x plus 9. Let's see if we can factor this. Well, you know how I just said you take the square root of 16? Let's do this. Let's take the square root of 9 as 3. You know how I said you take half of 8? Let's take half of 6. Oh, and that works. It's the same thing. If the square root of this number is the same as half of this number, then you have a perfect square. Okay, let's try this one. Let's say we have x squared plus 10x plus, what would you need to be a perfect square there? Well, remember, it's half of 10, so half of 10 is 5. And now you have 5 times 5 is 25. So x squared plus 10x plus 25 is a perfect square because you can write it as x plus 5, x plus 5. Square root of this number and also half of this number. If the square root of that and half of that is the same number, that's a perfect square. So take a look. Is this one going to be a perfect square? And you say, okay, what's half of 12? Half of 12 is 6. but then you say, wait a second, 6 times 6 does not equal 26. So that's not a perfect square. We could change this and make that 36, and now you've got a perfect square. Okay, that's it on perfect squares and difference of squares.